Huperzine A is an alkaloid compound extracted from a club moss called Huperzine serrata. It's been touted to have a number of neuroprotective and nootropic or cognitive enhancing properties, and it's even been suggested as a possible treatment for Alzheimer's disease. Huperzine A is the alkaloid compound extracted from club moss. The club moss has traditionally been used in Chinese medicine for fever, inflammation, and even schizophrenia. Because of its long history of use in traditional Chinese medicine, Huperzine A has now been studied as a compound of interest for its potential effects on a number of important systems in the body and the brain. Huperzine A has been reported to be a potent, reversible, and specific inhibitor of the enzyme acetylcholinesterase. This enzyme breaks down the major neurotransmitter acetylcholine, suggesting that some of Huperzine A's effects may come from generally increased levels of acetylcholine throughout the brain. For example, according to one animal study, Huperzine A was reported to increase acetylcholine levels in rats' brains for up to 6 hours after administration. Several animal studies have reported that Huperzine A may result in a more prolonged increase in acetylcholine in the whole brain when compared to other compounds that raise acetylcholine levels. According to one study, Huperzine A may work in a similar way to some Alzheimer's disease medications, which are also believed to affect the acetylcholine system of the brain. Although fewer side effects and somewhat more favorable pharmacokinetics are seen with Huperzine A. The potential increase in acetylcholine levels seem to differ between different parts of the rat's brain. According to a few animal studies, following administration, maximum acetylcholine levels were observed in the hippocampus after 30 minutes, and in the frontal and prefrontal cortex after 60 minutes. These observations suggest that Huperzine A may influence the function of different parts of the brain at different times. However, some research has also stressed that Huperzine A likely also has effects on other brain mechanisms that don't involve acetylcholinesterase. So this effect alone is probably not the whole story. It increases norepinephrine and dopamine, but not serotonin. This was according to one animal study. Early evidence from a study suggests that Huperzine A may have a few mechanisms that could help protect the brain from stress and harm. Some of these suggestive findings include muscarinic and GABA receptors that may play a role in some of the reports that Huperzine A protects against seizures. One literature review of Huperzine A hypothesizes that it may help to promote neuronal growth by stimulating the production and the secretion of nerve growth factor. One in vitro cell study proposed that Huperzine A may help to prevent and reduce cell damage from lack of oxygen or hypoxia. This protective effect may partially be mediated by the cholinergic anti-inflammatory pathway through alpha-7 nicotinic acetylcholine receptors. One animal study has reported that Huperzine A may help with inflammation in rats, in particular by reducing the activities of NF-kappa B signaling, which may happen both through inhibition of acetylcholine esterase or in other ways. In a systemic review of different interventions for Alzheimer's, combined data from multiple studies was used to suggest that Huperzine A may have statistically significant effects in reducing cognitive decline during Alzheimer's disease. However, while the early results are promising, there's some important limitations to note. For example, the quality of the studies is somewhat lower than the quality of studies of other medical interventions for Alzheimer's disease and other dementia-related conditions. According to some researchers, Huperzine A has been reported to prevent neuron loss during Alzheimer's, specifically by inhibiting the inflammatory response caused by the buildup of amyloid beta, which is the main factor believed to be responsible for Alzheimer's disease. In a related study, Huperzine A was reported to inhibit the NF-kappa B pathway in immune cells. This further suggests that it may help to reduce inflammation, which could account for why Huperzine A has been claimed to help slow down the progression of cognitive symptoms in Alzheimer's disease. At least one clinical trial in patients with Alzheimer's disease has reported that Huperzine A supplementation appeared to improve cognitive function and overall well-being in these patients. According to some early animal studies and clinical trials in humans, Huperzine A may be associated with enhancements in memory and other neuroprotective effects. For example, Huperzine A was reported to significantly improve memory abilities in adolescent high school students when compared to an inactive placebo treatment. Although the mechanisms behind this potential effect are still unclear, one animal study reported that Huperzine A may stimulate the growth of neuronal cells, known as neurogenesis, in the hippocampus of a mouse brain. This brain region is believed to be highly involved in memory. While preliminary a mood disorder, depression can also involve disruptions in cognitive abilities, which can be serious symptoms in their own right. According to one preliminary study, when used as an add-on or a complementary treatment to standard antidepressants, Huperzine A was reported to resolve some of the significant cognitive symptoms associated with depression. One early study based on self-administration of Huperzine A reports that this decreased the individual's perception of the effects of cocaine. The authors of the study proposed that Huperzine A supplementation may be a safe, complementary approach to help treat addiction, although more research would be needed to verify this potential use. Myasthenia gravis is an autoimmune disease where the immune system attacks acetylcholine receptors, leading to problems with voluntary movement and muscle control. It's most commonly treated with immunosuppressants and acetylcholine esterase inhibitors. However, some early studies have looked at Huperzine A as a potential addition or complementary form of treatment. According to one preliminary clinical study with 128 patients, Huperzine A was reported to alleviate muscle weakness in myasthenia gravis patients. Preliminary findings from some early studies suggest that Huperzine A could have a number of mechanisms that may potentially help protect brain cells from certain forms of stress and damage. Nerve gases and organophosphates are irreversible inhibitors of acetylcholine esterase. Some research has suggested that Huperzine A can aid in preventing seizures and nervous system dysfunction caused by SOMAN, which is an organophosphate. Additionally, at least one animal study has also reported that Huperzine A may also help with chemical-induced cognitive impairment in mice. Glutamate is an amino acid neurotransmitter that can kill neuronal cells by overstimulating the NMDA receptor, a process called excitotoxicity. This can be especially dangerous to older neurons. Huperzine A is an inhibitor, an antagonist of these NMDA receptors, which has led some researchers to suggest that it may help prevent the neurons from cell death due to the glutamate toxicity. In addition to binding to the NMDA receptors, some evidence suggests that Huperzine A may also help to reduce oxidative damage from glutamate toxicity, specifically by activating BDNF-dependent and mTOR signaling pathways. Findings from one cell study suggest that Huperzine A may also protect against oxidative damage from iron overload. In addition to some of the preliminary evidence suggesting that Huperzine A may protect brain cells from certain types of damage, there's also few early studies that suggest that Huperzine A may also help to protect the brain as a whole from certain forms of physical injury. For example, combination treatments with Huperzine A, together with other supplement compounds like vinpocetine, acetylcarnitine, N-acetylcysteine, alpha-lipoic acid, and fish oil, have been reported to help increase brain blood flow and improve cognitive functions in retired NFL football players with a history of concussions. In one animal study, Huperzine A was reported to decrease programmed cell death, or apoptosis, as well as to improve neurological symptoms in rats with spinal cord trauma. According to one Cell study, Huperzine A may aid in the recovery from brain bleeding by preventing damage to the mitochondria and postponing cell death. At least one animal study suggests that Huperzine A may have the potential for protecting the brain during infections. In a rat model of severe bacterial infection, or sepsis, Huperzine A was reported to protect the brain from damage by reducing the inflammation. According to some early animal research, Huperzine A may be an effective treatment for epilepsy. In other animal studies, Huperzine A has been reported to protect brain cells from overexcitement and death associated with convulsions. According to another study in mice, Huperzine A was reported to make certain brain circuits more resistant to seizures. According to some studies in human users, oral Huperzine A is absorbed relatively quickly, distributed widely throughout the body and the brain, and is gradually eliminated or removed from circulation at a moderate rate. According to an animal study in mice, levels of Huperzine A were reported to be the highest in the kidney and the liver 15 minutes after injection. After 12 hours, no trace of Huperzine A was found anywhere in the body. According to one human study, it was reported that a very high dose, 1 milligram, caused peak serum blood concentrations of Huperzine A to be reached at approximately 80 minutes post-ingestion. Additionally, half of the Huperzine A was found after approximately 288 minutes, or roughly 5 hours, suggesting that it may be necessary to take Huperzine A multiple times a day to achieve steady, continuous levels throughout the body. No build-up of tolerance, loss of biological sensitivity to the compound, has been reported from repeated or continued use of Huperzine A, at least according to one early study. Doses in clinical trials for Alzheimer's range from 0.2 milligrams up to 0.8 milligrams. However, for Alzheimer's patients, one study reported that a dose of 0.4 milligrams twice daily was required to produce clinically significant results, while only 0.2 to 0.1 milligrams per day was needed to produce detectable effects on memory ability in high school students who struggled with memory problems. Early evidence available so far suggests that adverse side effects are relatively rare. For example, no notable side effects were observed at doses between 0.18 and 0.54 milligrams, at least according to one human study. However, some other studies have reported occasional side effects, including cholinergic symptoms like dizziness, nausea, digestive upsets, headaches, and decreased heart rate. One of the only available studies on its potential interactions reports that Huperzine A is unlikely to interact with cytochrome P450, an enzyme involved in detoxing drugs and other foreign compounds from the body. For example, cell studies using human liver cells have shown that Huperzine A is excreted whole, which suggests that it may be unable to react with other drugs that are metabolized by the cytochrome P450 enzyme system.